right, Geometry, Chapter 6-2, Parallelograms. So, quadrilateral with both pairs of opposite sides parallel is a parallelogram. So here parallel, AB parallel to DC, and AD parallel to BC. Alright, there's going to be a few properties that we're looking at. All of these are going to make sense to you. So, if the quadrilateral is a parallelogram, then the opposite sides are congruent. Okay. Now, if a quadrilateral is a parallelogram, then the opposite angles are congruent. Alright. And then 6-5, if it's a parallelogram, then its consecutive angles are supplementary. So, X and Y are going to add up to 180 degrees. And if a parallelogram has one right angle, obviously the opposite angle would also have to be right, which would mean the other two would also have to be right. So if it has one right angle, then it has four right angles, and all the angles are right. Alright, here we go. Example 1. In this parallelogram, suppose that the measure of A is 55, and the measure of AB, this length right here, is 2.5, and BC, this length is 1 foot. Find each measure. So A, to find DC, well, DC is the same length as AB, so that's 2.5. Easy. Alright, next. The measure of angle B. We know the measure of angle A, and we know those two are supplementary. So they add up to 180, and A is 55, which means B has to be 125. Okay, find the measure of angle C. Well, angle C is the same as angle A, so it is 55. Alright, diagonals. To find diagonals, a quadrilateral, if it's a parallelogram, then its diagonals bisect each other. That means that this length from D to P is the same as from P to B. Okay, same thing for this diagonal. These are congruent, the segments. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So this triangle is congruent to this triangle. ABD and CDB are congruent. Alright, we're going to use those properties to solve for some of these variables. We want to find we want to find X right here. X. Alright, well, we know that this side is 27. This is going to be a lot of setting things equal when we're working with a parallelogram. Okay, so we know that this side is equal to this side, so we can set their measures equal. And then solve, we get 5.4 for X. If we want to find Y, well, I know that the diagonals bisect each other, so this segment is congruent to this segment. So I can set those two equal. So 2y minus 5 is equal to y plus 4. Solve for y, and we get y equals 9. Solving for z, there's z. Well, I know that this angle is going to be the same as this angle up here, since these are congruent triangles. So right here and right there. And we have parallel lines, so they're interior, alternate interior angles. So 3z is equal to 33 divided by 3. You get 11. Alright, we want to determine whether these coordinates determine the coordinates of the intersection. Okay, remember they're bisectors, so we're going to use the midpoint for this. Midpoint of FH. Alright, we'll use those coordinates. Remember your midpoint formula. We'll take x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And there is your midpoint. That's all there is to it. Like and subscribe to the Mastermind channel.